Hey everybody, we're going to talk about basic probability with the word and with the word or. All right, so here's a spinner. All right, and the question here, okay, so basically what we're going to do is we're just going to spin and land on a certain number, and the numbers are 1 through 13. All right, and so here's an or question. What's the probability that the result that you land on is a multiple of 4 or a multiple of 3? So the first thing to realize is that the word or here is indicating more possibilities, right? If I do something or something else, I have more possibilities, right? If I get to choose a chocolate ice cream or vanilla ice cream, I have more choices, right? So this is the thought of or, okay? More choices. So I stopped to think, all right, what if I land on a multiple of 4? Well, the multiples of 4 are 4, 8, and 12. That's 3 possibilities, right? 3 possibilities. Then the multiples of 3 are 3, 6, 9, and 12. That's also 4 possibilities. So I had 3 possibilities and then 4 possibilities in the second one. However, one of them is shared. They both have 12, so I can't count 12 twice. Therefore, there's only 6 possibilities. 6 possibilities. That's 3, 4, 6, 8, 9, and 12. So to find my probability, I would take 6, which is the number of successful outcomes, or you can call it satisfying events. The number of events that are multiples of 4 or multiples of 3. That's 6 different events. And I divide it by the total possible events. There were 13 possible outcomes. And so 6/13 is my probability, roughly 46%. All right. Now, what if I think of, turn some of this off. What if I think about this? So there's Algebra 2 class, 20 students. 12 of them play baseball. 12 of them play basketball. 13 of them play baseball. So you might ask yourself, how is that? 12 plus 13 is more than 20. Well, we have to consider that there are going to be some students that play both sports. All right. We've also been told that there's 3 of them who actually do not play either sport. So while some people can organize these thoughts in their head, all right, to answer the question, what's the probability that a student chosen plays basketball or baseball? In reality, it's best to really think about this with a table. All right, so it's a way of organizing our thoughts. So I'm going to organize my thoughts here by students who play basketball or do not play basketball versus students who play baseball or do not play baseball. So I know 3 of them don't play either. I know 12 students play basketball, and I know 13 students play baseball. So I put these numbers in the totals column. The rest of this is really an exercise of, can I fill in the blanks? Can I think backwards right here? Well, let's think of something, right? So if there's 13 students who play baseball, then there must be 7 students who do not, right? We can do it like that. We can also think, okay, if there's 12 students that play basketball, there must be 8 students who do not. All right, so I can think of 8 right there. I can think of 7 right there, because my numbers have to add up, right? Which means if there are 7 kids here, 3 of them don't play. That means 4 of them play basketball. All right. Continuing with my numbers, so that's going to be an 8. All right, and the only number that'll satisfy that will be a 5. So 8, 5, and 4. And just to double check, here's my answer key. All right, and it looks good. Okay, so now all I got to choose is the students who play basketball or baseball. That means most students, right? Really, it's everybody except for these 3 students. All right, so that leaves me a total of 8 plus 4, 12 plus 5, 17. And I've got 17 out of 20 students. All right, now what's the difference with and? If I would have had a question, basketball and baseball, then I would have had to look for the column that says both, and I only would have used one cell for that. All right, and that would have been 3 out of 20. All right, so that is how this works.